In this video, we're going to look more at the periodic table. You have already learned how to read the periodic table, but in this one we'll be looking at groups, periods, valence electrons, and trends. Just a reminder, make sure you write down what you see and what you hear. Feel free to pause and watch as many times as you need to, and I will let you know what you need to know. So, just a quick review over what the periodic table is. The periodic table organizes known elements. It was created by Dmitri Mendeleev in 1869 and started out with only 63 elements. Now there are 118. And the elements are grouped by similar properties and arranged by increasing mass. So the first thing I'm going to talk about in a little more detail is periods. Periods are rows on the periodic table. Those are the horizontal or left to right lines on the periodic table. The period number tells us how many energy levels or orbitals or shells an atom has, and remember the orbitals are what holds the electrons in the electron cloud. There's a total of 7 on the periodic table. If you look at the numbers on the left side, you'll know which period you are looking at. So for example, helium is in period 1. If you look at the atom for helium on the left, you see it's got 1 shell. Chlorine is in period 3. If you look at the atom for chlorine, it's got 1, 2, 3 shells. Potassium is in period 4. As you can see, the atom for potassium has 1, 2, 3, 4 shells. So you can easily look at an atom to figure out what period it is in, and you can easily look at an element on the periodic table to figure out how many shells it will have in its atom model. You don't have to draw every single atom model here, but you may want to pick one to include as your notes as an example of how you can figure out what period an atom model is in. Next up is groups. Groups are the columns on the periodic table, or the vertical lines top to bottom. Another term we use for groups is families, because elements in the same group have similar properties. There are 18 groups total on the periodic table, but in 8th grade we mainly focus on 1 and 2, and 13 through 18. We kind of skip over really discussing the transition metals as far as groupings are concerned. And the group number will tell you how many valence electrons an atom has. Now I'm going to talk about valence electrons in the next slide, but just so that you can have an example to include with this information. Helium is in group 18. It has 2 valence electrons. It's kind of a exception to the rule, but 1, 2. Chlorine is in group 17. It's got 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. And potassium is in group 1, and it's got 1 valence electron. Something else you may want to add is that the groups actually have different names. They're not featured in this video, but you will learn more about the names of the different groups and the properties of the different groups in class. Alright, so more on valence electrons. Valence electrons are the electrons located in the outermost shell of an atom. You can figure out the number of valence electrons from the group number, which I stated on the last slide, and elements in the same group have the same number of valence electrons. The exception to this rule is helium, because its group is supposed to have 8 valence electrons, but since helium only has 2, it's still got a full shell. Something very important to remember is that valence electrons determine the reactivity, or how atoms interact with each other. This diagram is just a little snippet of what you see to the right, but every single picture has the valence electrons in red. So as you can see, this is group 1. Every single atom has 1 valence electron. In group 2, there's 2 valence electrons. This is actually group 13, but if you look at the number before the A, it kind of gives you a hint as to how many valence electrons there are. So in this group there's 3. That's this over here. 14 has 4 valence electrons. 15 has 5, 16 has 6, 17 has 7, and as I said, 18 has 8, the exception being helium, but it does have a full shell like the rest of the elements in its family. Okay, so the last thing that will be discussed in this particular video is trends on the periodic table. The 2 easiest trends to spot are atomic number and atomic mass because they are written on the periodic table itself, and those both increase as you move left to right or across the periodic table and as you move down the periodic table. Metallic properties are slightly different. They're not written on the periodic table, so it is something that you're going to have to learn and remember, and those actually decrease as you move across the periodic table, which is why our nonmetals are over here on the left, and they increase as you move down. So if we're looking at, say, a group of metals, as you move this way, they get less metallic, and as you move down, they get more metallic. Reactivity refers to how reactive different elements are. And with reactivity, it's different for metals and nonmetals. So if we're just looking at metals, or the elements on the left side of that staircase, the reactivity decreases as you move across, so metals on the right are less reactive, and it increases as you move down. So metals that are at the bottom of the periodic table are more reactive. For nonmetals, it's the opposite. The nonmetals that are further to the right are actually more reactive, and further down, they're less reactive. Please make sure you include the exception to this reactivity for nonmetals rule, and that's group 18. Even though they're nonmetals, they're not as reactive as group 17 because they have full outer shells. Alright, so that ends your video. The last slide is a bit of a challenge for anyone who'd like to see whether or not you can figure out the groups and periods of the following atom models based on what you learn. So take a second to pause the video and see how you do. For this picture, the group number would be 14 because it has 4 valence electrons, and the period number is 2 because it has 2 energy levels. For this picture, the group number is 17 because it's got 7 valence electrons, and the period number is 3 for its 3 shells. And finally, the group number for this final atom is group 1 because it's got 1 valence electron, and its period is 3 for its 3 orbitals. That ends your video. Remember to watch it as many times as you need to, and if you have any questions, let your teacher know.